Recall that when igneous rocks form by lava cooling rapidly on the surface or very near the surface, there's not enough time for large crystals to grow, so the rock ends up with very, very tiny microscopic crystals. An example of that is the rock basalt, which is shown here below. So this gray mass you're seeing consists of zillions and zillions of microscopic crystals. You can't actually see any of them with the naked eye. Geologists call these kinds of rocks volcanic. And the texture of these rocks is known by the term aphanitic. That's the term here in blue. And aphanitic basically means that the crystals are microscopic. Now the opposite of this are igneous rocks which are formed when magma cools very slowly deep underground. Under these conditions, there's lots of time for the crystals to grow, and so the crystals end up large or visible to the naked eye. An example of that is shown by this granite here, and this thing right here, that's actually a crystal. You can actually see all of the crystals in this rock. Some are orange or pink, some are gray, and a few are black like this one here. But the point is, all of these crystals can be seen without the aid of a microscope. So this is a texture we call macroscopic. Macroscopic meaning that all the crystals can be seen with the naked eye. Geologists call these kinds of rocks plutonic, after Pluto, the god of the underworld. So you can think of these rocks as forming where Pluto lives. And the texture of these rocks is known as phaneritic. Phaneritic texture means all of the crystals are macroscopic. Aphanitic texture means that all of the crystals are microscopic. However, if we look at volcanic rocks, most volcanic rocks look like this one. This is a texture we call porphyritic. Porphyritic aphanitic. So what are we looking at here? So the gray material here consists of microscopic crystals. So all of this is microscopic crystals forming what's called the ground mass of the porphyritic aphanitic textured rock. So, sort of swimming in the sea of the ground mass are a few large crystals. So these black things here, like this guy here or that there, these are actually large crystals. These are large crystals, and I can certainly see them without the aid of a microscope. These relatively few large crystals living inside this sea of microscopic crystals are called phenocrysts. Phenocrysts. So the porphyritic texture is characterized by a few large phenocryst crystals in a sea of microscopic ground mass crystals. And the question is then, how does this form? Because this is actually by far the most common texture of volcanic rocks. So to understand how these rocks form, let's think in general about how volcanic rocks form at all. So here's a little cross-section of the Earth. My little tree here shows that it's a cross-section. And somehow we're going to generate magma deep down beneath the surface by some kind of process of partial melting. So somewhere down here we're going to generate some magma. It might be in the lithosphere, it might be in the mantle, it might even be in the crust. And then that magma is going to rise up because it's less dense than the surrounding rock. And if it could, it might make it all the way to the surface. But what normally happens is, as this magma rises, it reaches some depth where it can't rise any further, and it accumulates in a large reservoir of magma in the ground called a magma chamber. Now, why doesn't the magma continue to rise to the surface? Well, the rock above the magma chamber is relatively strong, and the magma simply can't break through it yet until a pressure difference exists between the the magma in the magma chamber and the surface, at which point it will finally be able to make its way to the surface. But until that pressure is created by this continuous addition of new magma to the magma chamber, the magma sort of sits there in a holding pattern, and it may sit there for days, or commonly weeks, or often years, or even decades, or millennia, or tens of thousands of years, waiting in this magma chamber for the pressure to be large enough to where an eruption can start, where this magma finally can escape, work its way up to the surface, erupt on the surface, and form a volcanic rock. So the question of how do the porphyritic textures form is answered by the time spent in the magma chamber, because while the magma is sitting in the magma chamber, right, waiting for conditions to get ripe for it to erupt, it's cooling. And as it cools, crystals form, and because it's cooling slowly, because the magma chamber is located deep underground, these crystals can and do grow relatively large to the point where they are macroscopic. Now, if this continued to cool until there was no magma left, right, we'd have a plutonic rock. But in this case, what happens is, before that happens, before this entire magma has turned into solid, it erupts. And what erupts actually is not just the liquid portion, but a mix of the liquid and the entrained crystals that grew in the magma chamber. And these crystals then, these phenocrysts, are brought to the surface and erupted along with the surrounding liquid. The surrounding liquid, of course, then cools very quickly. It quenches against the atmosphere to form microscopic crystals, the ground mass. And the larger crystals, the phenocrysts, then represent crystals which grew when the liquid was waiting in the magma chamber to erupt and then were carried up during the eruption. So that's exactly how we can see a texture like this. So we interpret this to mean then that the ground mass here, this ground mass, formed rapidly on the surface during the eruption. And the phenocrysts, these large phenocryst crystals like this one right here, these formed during slow cooling in the magma chamber. In the magma chamber, which existed prior to eruption. And again, the magmas spend anywhere from days to tens of thousands to, in some cases, hundreds of thousands of years in that magma chamber waiting to erupt. And during that time, large crystals, the phenocrysts, grow. Now, there's one other thing I want to mention here, and that is there is also a texture we see in plutonic rocks. This is an example of it here. This is an example of what is called a porphyritic texture. So all of these crystals are visible to the naked eye. This represents a magma which cooled very slowly deep underground. Yet some of the crystals, these ones that are in orange here, or these kinds of ones here, right? These large crystals here are much, much larger than the others. They may be 100 times larger than the small black and white ones that we can also see with our naked eye, right? So it does in fact have two different sizes of crystals, which is actually the origin of the word porphyritic, yet all of the crystals are phaneritic. Now, explaining how this forms is actually a lot more difficult because this rock did not have a two-phase cooling history. All of the crystals in this rock formed by slow cooling deep underground, and the explanation for why some of them just happen to be so much larger than the others has something to do with kinetics and is kind of beyond the scope of this course. But by far the most common type of volcanic rock and the most common example of porphyritic texture, and the one that you will need to be able to explain in this course, is the one that occurs in volcanic rocks like this one here.